Join us for a discussion on AI and streaming with Timothy Spann, Principal Developer Advocate at Zilliz. This podcast includes a live demo using StreamNative with Zilliz, with a live training available at Data Streaming Summit October 28th and 29th, 2024. Check the description for a link and 50% discount code.
My name is Dustin Nest. I'm a technical trainer here at StreamNative, but today we're here to talk to Timothy Spann, Principal Developer Advocate at Zilliz, which I believe would be a commercialized version of Milvus. But if you want to introduce yourself and Zilliz and Milvus, I'll go ahead and hand it over to you, Tim.
Sure. So, yes, I'm Tim Spann. I'm a Principal Developer Advocate at Zilliz. And Zilliz is the company behind the open source vector database Milvus. As people are familiar with StreamNative and Pulsar, sort of the same deal, really similar. You know, we come from the same cloth, develop in open source, make the best software you can, and then put a business helping people around it and making a really cool cloud.
Basically enabling people to use it without having to go back and learn how it was made, how to install it, how to productionize it. You guys make it a one-click, which we'll actually show a little bit later. I'm going to actually do a demo on your Zilliz Cloud.
Nice.
And so I'll include that and show people how easy it was for me to get started with your vector database.
Very cool.
So can you talk a little bit about what a vector database is for, an unstructured data, what type of data you can store in it, why you store it in that format, that type of thing?
Sure. So let's start from the beginning. Obviously, everyone needs databases. Now, the difference with a vector database is we grew up in the era of we have all this unstructured data that machine learning and AI are starting to need. And even before that, just to be able to search things like images has been very important. Unstructured data is, you know, most of the data in the world, almost 90% of the data in the world is unstructured data. And most of the time it's never analyzed because it's chunks of text, it's images, it's video, it's audio, it's, you know, PDFs, Word documents, Excel. It's the output of other reports sometimes, it's logs. It's data that doesn't follow any predefined data model usually. You don't know, you know, sometimes you get a big image, you get a small image, it's a dog, it's a cat. You know, it's all over the place. And before AI, you know, there wasn't much you could do about it. I mean, we started out, we were able to search it. You were able to match images, you know, which was helpful for doing things like if you ran a store, I could upload a picture of a shirt I liked and find similar ones. Very, you know, very cool stuff. But now, if someone has been asleep for the last 4 or 5 years, AI has exploded. And what's interesting about that is a lot of the stuff that's very cool is being able to work with images, being able to work with video, create images, create video, can converse with your data, converse with images and just, or PDFs or whatever, to be able to type something in that becomes a prompt and be able to ask questions of a model. Where we fit in is you get this data and to get it in a format that is the same language that these models speak. And to be able to do that, sometimes you don't need to talk to the model. Sometimes I just want to know what's in this document and just be able to do a smart search against it. Because with a vector database, we're not just doing a search of a keyword, or I'm not searching, when I search an image, I'm not searching the metadata. I'm searching the meaning of the image. Mm-hmm. I mean, with these deep learning models, we've been able to analyze what's in the image, store it as a multi-dimensional, large dimension array, and be able to find it by matching it up mathematically against other things. So there's no subjective. It's, you know, using these smart models, text has been matched that makes sense semantically against other text. Or now they've trained some models with image and text together
Mhm.
the same model. So now I can search, and that's been my fun new one, search an image with text and being able to get the right results that make sense. I want, not the keyword blue and cat. I want a blue cat, and it understands those things, which is amazing. If you go back a couple of years, you're like, how's that possible? Well, it doesn't even. I mean, it seems magical. It's pretty awesome. And then, just doing that with a library is pretty cool. But then, like anything else, I want to be able to store it and make that process repeatable, because these things are expensive. Running these models, embeddings, even when they are fast, because maybe the text is very regular or the images are small. If I have millions of them, or for us, billions, if I have billions of these things I want to be able to search, I don't want to keep doing it. I don't want to call an expensive AI model every time. If I can improve that process by storing it in a database, it makes a lot of sense. And with our database, we could do all the things you need to be able to optimize this process, manage all the different search libraries, make it so you could do things that make your results better, standard database practices, like having filters on there, different types of indexes. For us, making your data durable. And part of our architecture includes Pulsar, or Kafka compatible messaging, because we have a distributed system to run this database, as most people do, with compute and storage separated, communication between layers, so you could scale out very easily. A lot of, when you start off building a storage system or a database, maybe like one big server, one big node, and we are completely distributed, ability to run on Kubernetes, or if that becomes too hard, we hide it behind our fancy cloud for you.
If we break it up into pieces, it sounds like you have to create those embeddings, right? You take the model, you have your data, you create the embeddings.
Yep.
That's not something you guys do. That's the large language models, all the different foundation models. If you need to create embedding, you need a place to store them, and you need a place to search for them.
Yes.
And that is what you guys do, is the storing and the search, and then all of the other things that you need to do that are around it to productionize that and all of that type of thing. What really came, or why was Milvus originally formed then? What was lacking for other vendors in this space related to vector storage and search as to why Milvus came about?
Well, Milvus was the first.
It was the first. Okay.
Milvus came out of university research in China, and it started to form up. It started off like everyone else, just a simple layer on top of one of the search libraries. The search libraries came out first, like Face from Meta, and a bunch of those libraries, which were good at being able to do this. You take one file, apply the library, get your results, and do part of what you said, make it available for storage or be able to search it. And then we started off the way you'd start any project, build one simple database. That's one big, simple process. Who knew that you'd have to scale out to enterprise, global internet scale? Because who knew this would be used by everybody and needed for everything now?
I mean, when you first start creating these things, you don't know if they're going to take off. You're not going to build it for the largest scale that you can imagine from the start, because you don't know if this is the technology that's going to be important in the future.
Yeah, you build it so it works, it meets your use case, it works, and does the basic things. But we were fortunate as very early on, because of where they were running, a lot of people were interested, and they started to realize this needs to be a distributed architecture. That's when things like Pulsar come into it. Compute and storage are separated, run on Kubernetes, so you could scale out as many nodes as you want. separate querying and indexing and storage, store things in, standard object storage, add all those things that you need, backup, replication, high availability, be able to partition and shard data, aggregating data, being able to do CRUD, full life cycle management of the data, supporting multi-tenancy, things that make logical sense to people who wrote Apache Pulsar as well. I mean, these are things you need to scale out.
I'm hearing all the same story that I hear at StreamNative.
Yeah,
and then it becomes, that's why you want us to help you productionize it, because we are experts on how to scale these things out, how to scale them horizontally versus vertically, how to keep your SLAs and your uptimes for these types of systems, because they're going to become integral parts of your enterprise. They're going to become part of your production system. So you can't afford to have any hiccups. So you want the experts, the ones who created the software in the first place, to be the ones who manage your deployment of it.
Yeah, it's the logical, once you get past the phase of trying it out, trying a couple use cases, I think most of the enterprises in the world have seen there's value here, whether it's for helping with people write code, helping to interface with your documents and your data, being able to generate SQL for you, being able to handle some low-level, previously human functions. There's a lot of activities that are being enhanced by AI, and those same activities touch enterprise data. They touch a lot of different systems, which brings distributed programming as a requirement, which brings being able to have things repeatable, scalable, and stored, which is why you need, something like Milvus, a vector database, to be able to not make extra calls to your models when you don't need to be able to give you better quality results, reduce hallucination by having things stored and being able to look them up near instantaneously and get back data to make your prompt smarter, to make it, almost trivial to get the results you want back. Milvus stores everything about all your documents. Like for us, we use Milvus to store information on Milvus. So you search Milvus, get the results back in Milvus on a specific thing, get it as a well-crafted prompt. You tell the AI, just search this context I'm giving you, and you get back good results. I mean, it's why wouldn't you do that? And, why wouldn't you own your own data? Why don't you keep your data safe and run in whatever environment makes sense for you? We work with any of the models, but, open source and models running in your enterprise makes it very easy. Again, having the whole suite there.
And you say you work with any of the models because all the models create embeddings, vector embeddings, and basically you can store any of those. They just might be different sizes, different implementations, but it doesn't really matter. It's still a vector embedding. You guys are optimized for storage and search of those embeddings.
Yeah. Well, and two is we deal with models in a couple of different places. Obviously, embedding is probably the most important for our storage. I mean, because we take your data, use the embedding to get it in, but eventually, you're probably using our data to talk to another model. Maybe many is part of an agent workflow. As it comes through, find something you need, add that to your context, call someone, call another thing, maybe in real time through Pulsar or Kafka API, and then keep going. But I mean, being able to call a model with the smart stuff is important. So how we connect to them, whether it's through, real time with Pulsar or whatever means you use, is almost as important as those embeddings. And what's nice is we have those things very open. So it's very easy to use different models as they come up, because there's new ones all the time. You don't have to use OpenAI. You don't have to run ones from, one specific type of model. So, I mean, you could pick OpenAI ones. You could pick ones from, pull them off of Hugging Face. You could use Llama 3.2. Ton of different options there, whether they're for dense or sparse ones. And we've put a list of some of the most popular ones on our website, make it easy to go through there and go, oh, maybe I want to pick this one versus other one because I'm doing this type of data. Again, that's why you might want to pick an enterprise cloud, because picking the right model for every use case is not always trivial. There's ways to run things like Ragas to test multiple ones out, but having people who know which ones you should pick, and part of the Zilliz Cloud automatically picks the right index for you, which is pretty cool.
Nice. Are there any specific use cases that you're working on right now that you are most excited about that you can talk about?
There's a lot of them. What can I talk to? Well, what's been the most interesting to me is some of the multimodal stuff. And so
simultaneously?
Yeah, that's really cool. I mean, I'm waiting for Llama 3.2 to have the visual models come into a Llama, because I really like to be able to run everything in a local environment. It's a great way to help people learn, so they don't have to have a paid API every place. So it's a fun way to keep that simple for doing a workshop. But there's so many different new models. My new example is a fun one because we are in October now, and I'm using Milvus as a ghost trap to be able to acquire and store ghosts and make them available for search. So there's, images and text. I'm like, well, how would I store a ghost? Well, what is a ghost? A ghost is ephemeral. Well, that sounds unstructured. But what's less structured than something you can put your hand through? So I'm like, well, that's got to be unstructured data. I can store. No reason why I can't store that. So I'm working on that. Real world use cases, I've got some interesting stuff with edge devices, because some of the new NVIDIA devices now have some serious amount of RAM, storage, GPUs, and we can run our standalone and our light version of Milvus right on those devices. Much like you're able to do with Pulsar. So, I mean, that's probably some use case I should look at, is using Pulsar to distribute some of my data between edge devices, devices that may be sitting in a robot. Well, they're not sitting there because the robot's moving, but the idea. So, because, you have the multi-cameras and the sensors able to interact with other machines and with people in real time and be able to do speech, text, video, back and forth, search, and, talk to models right there using things like NVIDIA's NIM services. And then it kind of makes sense to communicate between nodes in like a robot cluster through something like Pulsar. That might be something to think about.
It sounds like there's a lot of exciting things to work on, for sure.
Oh, yeah. There's a lot of the basic use cases are really easy now.
Yep.
So, which is great. Like, if you want to take, a few thousand PDFs, Word documents, and converse with them and be able to do that cost effectively in production, you could do that without much effort with Zilliz Cloud. Boom. You're set. You scale out as big as you need to. There's not much difficulty there. But now that you start adding more layers and agents, as your success grows, once you start pushing the boundaries, then you start getting to the interesting areas that may require additional assistance.
Yeah. So I did want to get into a demo during the podcast. it's going to be a very simple demo, but I want to show how users can integrate streaming with Zilliz and a vector database. So let's say you had data coming in, you wanted to create an embedding out of it, and then automate the process of moving that over into the Zilliz database.
Cool.
Before I do that, I just wanted to introduce, for those of our listeners who aren't completely familiar with StreamNative and Pulsar, as you had mentioned, Milvus is to Zilliz as Pulsar is to StreamNative. Pulsar is the open source software that is part of the Apache Software Foundation. It's a open source, cloud native, massively scalable, and elastic unified messaging and streaming platform. And StreamNative was built by the founders of Pulsar. StreamNative has the one StreamNative Cloud. We have a lot of capabilities that we've added. We have Kafka compatibility for both the protocol and the ability to deploy Kafka connectors, which we're going to be talking about today, because the Milvus connector to move data from Pulsar into Zilliz is based off of the Kafka protocol, the one that we're going to be using today. But StreamNative also does things like storing data in open formats and lakehouse storage, like Delta Lake, as well as Iceberg. The idea of streaming combined with AI and creating embeddings is something that we want to explore as a way to automate a lot of these tasks and to make them faster. So what I want to show quick, and I'd like your comments as I demonstrate this, because you are very familiar with Pulsar as well.
Love Pulsar.
Let me just show you what I have here. I'm going to share my screen. But here I have a Python function. I think you said you've worked with Pulsar functions before.
Yes.
Pulsar functions are a serverless way to deploy your code. Here I have a Python version of it. Java's super popular to use with Pulsar as well. But I'm going to be using OpenAI here to create an embedding. So when I deploy this particular Python function, I'm going to deploy it so that all data that goes into this topic here, embed input 1, becomes a trigger for this function. It triggers off of it, creates a client. Actually, the client's only created when the function first deploys or is run the first time, and then it's held in the context or the self. But it's going to reach out to a website. So I'm going to publish a website to that input topic. It's going to use Beautiful Soup, scrape the website. In fact, I'm just taking the title of the website, but this could be you're scraping anything essentially. Makes a call over to OpenAI, creates the embedding using text embedding 3 small, and I send it over to an output topic where I have the string as the primary key. I save the original text, and then I save the vectors database. I think these are length of 1536, I believe, for a text embedding 3 small. And then it just outputs that to a topic. Now, the reason I output that to a topic is because I'm going to use your connector deployed in StreamNative Cloud. So let me go hop on over there. So here we've hopped into the StreamNative UI. This is the cluster where I deployed that Pulsar function. So if I go over to functions here on the left, I'm in my tenant and namespace that I'm using. Here's the Pulsar function. It says that there's been 3 messages sent across. Those were sent before the start of this demo today. I'm going to send one over in just a minute. But this is the Pulsar function running. It has an input, as I said, embed input 1, and then it outputs to embed output 1. I've already deployed your Kafka connector from Milvus.
Nice.
And so if I go over to connectors, you can see there's Pulsar sinks and sources as well as Kafka sinks and sources in the UI. Here's the Milvus sync connector that's currently running. And I can go over here into the edit, and we can look at all the configuration. Authentication's all saved in secrets. But the most important thing here is I'm saving to my collection 5. Let's hop on over to your cloud. So here I am in Zilliz Cloud, and I have a collection called My Collection 5. If we go to the overview, you can see here's the primary key, the vector, and then the original text. These are the same 3 fields that I was publishing as the output of our Python function. So what I want to do is I want to publish some sort of URL to the input of the Python function. The Python function is going to scrape that website, create an embedding, output that embedding into a topic, and then that data that's in that topic will get picked up by the Milvus connector and show up here in my collection 5 as an entirely automated streaming fashion. So let me hop on over to yet another IntelliJ where I'm going to publish that initial URL that's going to trigger this flow. Okay, so here I'm actually using some Pulsar Java client code, and I'm just going to publish a message. It's the website to our dev portal on our website. So a little plug to the dev portal I helped create. And I'm going to publish that into this embedding input 1 topic. So I'm just going to go ahead and right click on this, run it. That's going to trigger the Python function, as I'd said, to go ahead and reach out to that website, get some information off of it, in this case, just the title, create an embedding based off of that, and then the connector is going to immediately sync that over.
It's very cool to see Java to Python, and doesn't matter what language you're using. That's the nice thing of that isolation.
Yep. And here we go. I know I did some editing in post-production, but Tim, if you can verify, that was literally a matter of seconds. I'm over here in Zilliz, and here is the record here that has our vector, which was created by OpenAI and then sent over here by the Milvus Kafka connector, or connector that works with the Kafka protocol from our end, and then publishes probably to yours with your APIs. Great. So what do you think?
That's great. I mean, cool? That's as fast as you want. I mean, that's pretty cool. It's nice to see too. It provides that isolation. I mean, code in whatever language, whatever existing app you have now, push to Pulsar or Kafka, and then whatever processing you need to get that into Milvus is done and gets distributed right there. Everything distributed. They can all be living in different places. That's powerful. Very cool.
And then I'm not showing today, but I'm working on, I mentioned to you earlier, was now that you have your data inside of Zilliz, the Python functions can, let's say you have a separate workflow. Let's say you have an email that you need to send to a customer and you want to customize it. You have some user information about what they might be interested in that's inside of your Zilliz database. In the Python function, I actually can call a similarity search.
Nice.
Get data out of Zilliz. And then what we can do is, if you get maybe multiple entries, if you want to summarize that data, you can then call some foundational model to summarize the data for the user. So these are all things that I've been exploring as ways to automate some of your workflows that use AI. And as you saw from the Python code, it's not very many lines of code. It's a very simple call to OpenAI, structure the data in the format, the output, that you basically have the primary key, the vector, the original text. In this case, I included the original text because when I want the similarity search back, I want that text in its original form to then play with. So the vector was used to find the similarity information, but the original text is then what I want to present to the user, or a summarized version of it. So this is what I've been playing with, of trying to automate these things with streaming and then making it super easy with Python functions. So you literally create a few lines of text and upload those. I'm going to be training on this at Data Streaming Summit 2024 in a few weeks at SFO in San Francisco. And then I'm going to put this material up for free as well on our training website. And I'm going to showcase the Milvus Connector and Zilliz Cloud and how easy it was to get all these things to work.
That's really cool. And you could add things like filtering and other stuff when you're doing your similarity. You might want to add some other fields when you need them.
Mm-hmm.
The scalar fields sometimes come in helpful for metadata or for limiting the results you get back. Again, lots of cool stuff you could do here.
And then I'm hoping I can direct people to your guys' website on the APIs that they can all use for all of those vector, for all the different types of searches they can do on the vector database. Because I don't want to be the one teaching them exactly how to do it. I want you guys, I want to say, this is how easy it is to use Zilliz. And then I send them to you, and then you guys are like, here's all the ways you can do it to improve it. Yeah.
And then we hand it back for you for streaming. And we get to do that in person in a little more, well, a month and a half. My friend and your friend David is coming to New York to do our meetup, and he's going to talk Pulsar and Kafka. I'm going to talk Milvus. I'm sure he'll have some interesting stuff to show off how far things have advanced in a month.
He knows I'm working on this, and he already wants this. So we already talked about it.
Yeah, so that should be, people should get to see some really cool stuff. Maybe even we'll have time to do a little hands-on for somebody there. If you're going to be in New York towards the middle, we're doing a meetup, and we'll have StreamNative there. Perfect time to get real-time AI with Pulsar and Milvus in your pocket. Learn it, try it out.
Yeah, I'll be sure to put a link to the meetup into the description of this video once I get it uploaded to YouTube, so that people will be able to find it. And maybe I'll even make a little promo video out of just this discussion, so that we can promo that meetup as well.
Yeah, it should be pretty cool. I mean, there's not many people thinking of being able to do that in real time.
Yeah, and that's really what we want to get people excited about. And I don't want them to have to struggle with learning how to get Python functions working in Pulsar. It should be that should be the easy part. And me, as the technical trainer, I should be able to get someone up and running in 5-10 minutes.
That's awesome.
In our StreamNative Cloud, and then all they have to worry about is their use case. Because honestly, to get connected to Zilliz is super easy. You just need your endpoint and your secret. And
cool.
It's actually very, very easy once you have those to get connected. And the Milvus connector, I've tested it out, works great on our Kafka Connect that's running in the background to be able to deploy Kafka connectors. So we were super excited to get all this up and running. So now I kind of want to show it off to people, and then people get excited to use it, and then I'll send them over to you.
Very cool. Yeah, we will definitely show that multiple ways, because that's a really nice way to do that. And so many people are already moving data around with Kafka compatible APIs and Pulsar. Want to tap into that. Do some Pulsar functions to do whatever enhancement enrichment you want. Take your regular data, enable it to be available for AI, get it into Milvus, and it's just data got there. You don't have to write special AI pipelines.
You might already have the pipeline there for other purposes. Just add another subscription onto the topic that has the data, and then send that over to Zilliz as an embedding. So the data, it's not like you need, like you said, you don't need to build a whole new pipeline. You might already have data that you're interested in integrating with AI. Just add another subscription on that topic and format it in a way that you can create the embedding with, which is kind of how I'm thinking of it. It's not start from scratch with all new use cases. Think of the use cases you're already doing, and how can you augment them with AI? I think it's a really exciting way to think about it and to get started doing it without having this overwhelming project that you need to bring off the ground. It's kind of how I'm thinking about it.
Yeah, it's pretty awesome. I mean, CDC coming from any number of tables, anything you subscribe to and you push to Kafka or Pulsar, like bots from different chat networks, logs. I mean, there's a ton of data that's already in there, IoT data. All that data is pulsing through your Pulsar already. Tap that with a simple function that doesn't change anything else. Whoever's using it now keeps using it. You don't have to add some kind of special batch, special pipeline. Tap your existing data in real time, and then magically it's available for any AI application.
It'll probably start out as a research project, get the data in the format for AI, get it into as an embedding, get into Zilliz, let your engineers start playing around with that data, see what they can do with it, and then eventually build that back into your pipeline. I think we are running out of time, but I think I would like to finish with you being able to talk about anything that is pretty much everything you're working on is probably new and I think the whole field.
Just a roadmap.
But yeah, if you want to talk a little bit about what's coming up next, I think it'll be good for our listeners to be able to know what you guys are working on for the future, so that they can, if they get started now, they're ready to implement whatever you have coming next, right when it's out the door.
Yeah, I mean, unfortunately, with the world of AI, there's a new model every minute. So those will keep coming, and know that we're making sure we're enabled for that. We are adding new features that'll be coming out in Milvus 2.5 and Milvus 3 that are in the process. More advancements for doing sparse vectors, which have a couple of interesting use cases. Something that's new that some people haven't looked at is Milvus has the ability to store multiple vectors in a single row in a collection. And a lot of those, and they don't have to be the same type of data or embedding type. So I can put images, text, all in one row in a collection, search them differently. Or if you have something like a clip, be able to search image and text ones using the same embedding, have multiple ones there. We do hybrid search. That's getting more features there, which is pretty cool. We're adding, there's always more improved image and multimodal embeddings coming, more features with re-ranking. There's some improvements happening for search. There's support for blob data types coming. So you could make it easier. So like you said, you put that text there, which goes up to, 64K worth, but maybe you want the whole document in one piece. So we're working on being able to have a full blob in there. There's we're adding more data types coming as people have asked for. I mean, we've added, arrays and support for JSON, and we've added data types for floating point 16. Those are already there, but advanced text filtering, primary key dedupes, being able to reduce some of the memory footprint, adding date, time, and GIS stuff. So you have, more geolocation features in there without having to, write your own code there. Improvements to the storage format, be able to modify schemas after data is already there. There's a lot going on. Support for some new theories that are coming out there, like Copoly are coming. All these things. Of course, something magical comes out tomorrow, and that is a game changer. We'll start working on it. I mean, that's the great thing when you have.
Yeah, I think the key here is it's an active development because new features are coming out all the time. New requests are coming out all the time. So you guys are basically staying on top of the game, always keeping up with people's requests, making sure that you're
basically. There's always new fun stuff to do, new libraries, because we use the existing libraries from our friends at Meta as we collaborate on things. And we collaborate with a lot of our users who are, on the cutting edge of these systems. The people who are hitting the multiple billions of vectors, they come up with great ideas. I mean, that's the great thing about open source collaboration between the users, the developers, different companies working together on these things to make them better. They're doing that through a foundation and a community of like-minded open source data enthusiasts. Again, meetups every month all around the world. I mean, it's something. Stay involved, because you come back in 6 months, you'll be like, oh, where'd all this new cool stuff came from? Well, see that early so you get to do things easier and better. Just every month a new change.
Yep. Well, I want to thank you for taking the time for this podcast today. sounds like there's a lot going on right now. I'm going to put more information in the description of the podcast for the meetup. I'll get some information from you on what is the best way for people to get in contact with you. I'll put that in the description. We're having a training at Data Streaming Summit for Pulsar and StreamNative, as I had mentioned, where we're going to be talking about this. I'll be having people deploy Pulsar Functions and the Milvus Connector. And then that training will eventually be online for free. So I'll be putting that in the description once I've finished putting that together. So there's going to be a bunch of information on how to get in contact with either Tim or me on anything we talked about today. But again, I want to thank you so much for taking the time today to talk about Zilliz, Milvus, vector databases, AI, everything that's pretty much relevant right now. So thank you again, Tim.
No problem.
Thanks again for listening. Be sure to check the description for training resources on streaming AI, including examples using Zilliz with StreamNative.